I'm going to use the same context here as an example with the 4 students in the fall and the spring, but I'm going to change the numbers. And the reason is that the differences for each pair were actually similar for several of the students in the previous example. And I don't want to do that this time. I want to have differences that I can differentiate. So I'm going to use a slightly different data example, but the same setup. Fall, spring. So let's say the numbers are 0, 3, 4, and 2. And then over here, let's say they're 1, 5, 0, and 2. Okay. And I'm going to ask the question, is the difference positive? Well, let's see, 1 minus 0 is positive, so it is. 5 minus 3 is positive, yes. 0 minus 4 is negative, so it's not positive. 2 minus 2 is 0. It was not positive, but what I'm actually going to do is just cross out this entire row. That's how you do the signed rank test. Just like with the sign test. If it's not a positive difference or a negative one, forget it, right? We're just not going to include it. Okay, then we're going to calculate a difference. What actually is this difference? So 1 minus 0 is 1, 5 minus 3 is 2, 0 minus 4 is negative 4. And we're going to take the absolute values of those differences. So 1, 2, and 4. And then we're going to rank them. Okay, what's the smallest one? Well, 1 is the smallest of those 3 numbers, these 3 numbers. What's the next smallest? 2. And what's the third smallest? Well, it's this number 4. Those are the ranks of the absolute differences. All right, so how do we actually calculate S? We find all of the ranks where the difference was positive. So here's a positive difference, and here's the rank. Here's a positive difference, here's the rank. This one's not positive, so we'll exclude this rank. S is equal to the sum of the ranks where the difference was positive, which in this case is 1 plus 2. It's equal to 3. That is how you calculate the signed rank test statistic. Okay, so why would we do this? Well, first of all, it has the same advantages as any non-parametric randomization or permutation test. Let's say let's write that more clearly, as any other non-parametric randomization or permutation test. You've seen me list those before, but those are the fact that it works even if the data set is small. We're not going to assume that we have any particular distribution like normality. It also has the same advantages as the other rank-based tests you've seen, which is the rank sum test. In other words, it works even if there's outliers, it works even if there's censored data, but it also has the same disadvantages. So, for example, we throw away the actual data values. But not as much as we did with the sign test. At least now we're taking into account which differences are most big. So I guess the other reason to use this here is it actually is appropriate for pairs. You better be using paired methods for paired data. Okay. So what makes S so big? Like what makes S big versus small? What affects S? Let's think about that.